Hi and welcome back to another Mr. Talbot Maths video. This week's problem is quite a difficult one, to be honest, or at least I found it a little bit trickier. And I'd be interested to see if there are ways that you can find this in a more exact format, some more exact angles and things like that. So hopefully you'll see what I mean when I get into it. Now, if you want to have a go at this problem yourself, pause the video now. Otherwise, I'm going to show you my solution. Okay. Right, without further ado, let's get on with the problem. So, we've got to work out quite clearly the area of this orange section here. First thing you'll want to do is find out the side length of this square. So Pythagoras, 5 squared, add 10 squared, that's 100, add 25, and you square root that, and that gives us 5 root 5 as the side length of the square. Okay, some angles now that we know as the next bit. So basically this angle here, to work out the angle next to it here, we do 90, take that away. Now, this angle would be the same one, okay, because what you end up having is this is a right angle in the corner, and if you take away that angle, you get left with the same amount as you have here. So, they're the same, and what I'm going to call those for the moment is inverse tan of 2, 10 over 5, because tan is opposite over adjacent. Now I'm just going to identify any corresponding angles as I have done there, so that I don't have to keep writing inverse tan of 2. Okay, now the next bit, or the next thing that I wanted to do here, or the next thing I noticed at least, is I've got two triangles here with the same angles in. And I know that because one's a right angle and the other is the same angle. So I'm going to do a quick sketch of those. That's got a side length of 10, and this left-hand one has got a hypotenuse of 5 root 5 rather than 10, and it's got a base of 5 and a height of 10 there. Okay, now, because these are similar triangles, what I can do is use a scale factor to go from the side lengths of one to the other. So I'm going to times the hypotenuse here by, it's going to be 10 over 5 root 5. Hopefully you can read that. I'm having to keep things quite small because there's going to be a bit of working out. So if I do the same with the bottom, so times that by 10 over 5 root 5, that will give us a side length of 2 root 5. Okay, now if we do the same, or if we just actually think about the scale factor between the base of this left-hand triangle and the height of it, well, it's double, so the height of this would be 4 root 5. Okay, so the height of that there would be 4 root 5. I'm not going to put that on at the moment, but that's useful to know. This bit down here is 2 root 5. Now we know that this length here will be 3 root 5 because the full side length of the square is 5 root 5. Okay, now the next thing I spotted is that this angle here has to be 45 because we've got a diagonal of the square. So that's 45. We've got a right angle. This is 45, which means that this is an isosceles triangle here. These two lines to show that, which means this is also 2 root 5. And because we know the full height of this triangle is 4 root 5, this must also be 2 root 5. Now I'm not going to put that on because it turns out that actually I don't need that, and I'm trying to keep as much clear space as we can for the working out. Right, now the next thing that I did from here is I used, because I've got a side, I've got an angle, and I've got a side here, I used a cosine rule to work out the length of this side. And the cosine rule, if you've forgotten, a squared is b squared plus c squared minus 2bc cos a. So what I did, my a squared is this side here. I did 10 squared plus 5 root 5 squared minus 2 times 10 times 5 root 5, and then times cos, and then inverse tan of 2. You can just about see that. Just keep it on the page. Now that's a squared, and that gave me an answer as a squared of 125, which you might recognise from earlier. If we square root that, we get 5 root 5. So that means that this side here is the same as this side down here, and so we've got another isosceles triangle. Now, because it's an isosceles triangle, this angle up here must also be inverse tan of 2. I'm going to work out the length of this side here, going from here to here. Okay. Now I'm going to do that because this angle, this one here, is going to be inverse tan of 2 take away 45. This angle is inverse tan of 2, and so this angle up here must be 180, take away inverse tan of 2, take away inverse tan of 2 minus 45 down here. Now, what I've got is I've got a side here, an angle opposite a side. What I also need is another angle opposite another side. Well, this angle is opposite this side, the side I want to work out, and this 10 is opposite this angle, which I can put in terms of sine and inverse tan. Okay, so I'm going to use a sine rule. The sine rule, A over sine A is equal to B over sine B, or the inverse. Now really, actually, I should have done that as lowercase a and lowercase b. Okay, so using this, what I'm going to do, I'm going to write 10 over, now I'm going to do 10 over this angle. Now this angle here, I have to do sine of that angle, is going to be 180 minus inverse tan of 2 minus this angle down here, which is inverse tan of 2 minus 45. Okay. Now, what I'm then going to have to do is this side divided by sine of this angle is equal to all of this. So I need to times by sine of this angle. So I need to times by sine of inverse tan of 2. And that will give me this side length here, which is the one that I need to work out the area of this triangle here. So that gives me an answer of 100 root 2 over 7 root 5. Okay, so that's this length here, the full length. Now I could take away this side, but actually again that's not going to be helpful, so I don't want to do that. Right, so the next thing is I'm going to work out the area, and I'll just highlight it to make it a little bit clearer. I'm going to work out the area of this triangle here. Okay, so that's the area of the triangle I'm working out now. Area of this triangle, I'm going to do that. I've got a side, I've got an angle, I've got a side. I'm going to use half AB sine C. So a half of this side, which is 5 root 5, times by my 100 root 2 over 7 root 5. So that's a half AB sine C, so sine of 45. That gives me an answer of 250 over 7. So that's all of this section here. I'm now going to take away the last bit, which is going to be a half of 2 root 5 times 2 root 5. Okay. So a half of 2 root 5 squared. That is going to give me an answer of, or 2 root 5 squared, 4 times by 5 is 20. That's going to give me an answer of 10. Now, taking that away, I've got 250 over 7, take away 10. That gives me an answer of 180 over 7, which is my final answer and the answer to the area of this orange section. Okay, I hope you can see why that was a little bit tricky. If you can come up with any better solution, I'll be very interested to see it, particularly one which deals with things perhaps a little bit better than inverse tan of 2, because I didn't particularly like doing that. So yeah, if you did find anything better, please share it in the comments. I'll be very interested in seeing different ideas and different solutions, as I always am. Okay, thank you for watching, and I'll see you in the next one. Bye bye.